All right, guys. So the previous class, good evening once again. The previous class, we have been looking at various charts, how to present our data. And we would have looked at these charts and we would have learned how to calculate the various portion of the charts and so on. Now, today we want to look at raw data. And then now from here, we'll see how we can collect the data, how we can organize the data, how we can distribute the data. All right. So from your point of view, I mean, most of you have done your SBA, so you would have done some collection of data. So can anybody tell me what's your interpretation of raw data? Ms. Tulloch. Are you there, Ms. Tulloch? Are you there, Mr. Campbell?
Yes, sir.
All right, give me your interpretation of raw data, Mr. Campbell.
Raw data is probably I would say unprocessed information. Or
Say that again.
I would say unprocessed data.
Unprocessed data, all right? Or disorganized data. There's no order to the data, so it is disorganized. So in other words, you just go and you collect the data. You have not arranged it in any form that can be meaningful. So so once we collect the data in that state, it would be known as raw data. Now, when you do your survey and you collect all of the information on your survey, that would be just raw data, right? So what you want, the raw data by itself doesn't have much meaning to us. The only time the data has meaning is when we start to organize the data. And by organizing the data, we can look at the data, we can find out some things about the data. We can find out about the averages. We can find out about the frequency. We can find out about whatever trend we are seeing with the data, all right? So until we are able to do that, the disorganized raw data don't really have much meaning to us. All right, so we're going to be looking at how to deal with our raw data. So first and foremost, definition. Now, so raw data collection are collected information in an unsorted or disorganized form is called raw data. Now, one of the key things that we try to do when we get the data is to put them into some form of frequency distribution. Now, you would have known the word frequency before. So when you hear the word frequency, Ms. Wason, what the word frequency tells you?
Often occurring, sir.
Okay, so frequency, not necessarily that it is often occurring, but it tells you how often it occurs, right? So it can occur very often, it can occur less than average. So the frequency really tell you the number of times something occurs. All right, so if we are looking at the data, we can arrange them so that we can say how much time each of the data occur. And so when we arrange a table and put the data in it based on the frequency, then we call it a frequency distribution table. All right. So one way of organizing raw data into order is to arrange them into a table of frequency distribution. A tally chart is useful in finding the frequency of a raw data. Now, we talk about frequency already. So the frequency is the amount of time the data occurs. All right, now here we have a table giving an example of how we can organize some data. Now, this data has to do with marks obtained from students in a class. Now, you would have a variety of different marks, but we notice that the marks have a certain range. The mark starts from 1 and it goes up to 8. So in other words, the lowest mark is 1 and the highest mark is 8. So that's a range for the mark. Now, what we can do now, we arrange the marks in ascending, what we call ascending now. Ascending is when you go from smallest to largest. All right, and from smallest to largest is ascending, and descending is from largest to smallest. So arranging the data here from smallest to largest. So we have 1 up to 8. Now we may also now take into account how many times these numbers occur. So we notice that we have a middle column that we refer to as the tally. Now, the tally column is just a means of helping us to keep a track of the number of the data. So easily, sometimes when we are doing a tally, we just put down a stroke to mean it occurs 1 time. If we put down 2 strokes, it occurs 2 times and so on. So by putting down these strokes, whenever the strokes are mounted to 5, then we would start a new set of strokes, right? Generally, when we have a bundle of 5, you usually have 4 strokes with 1 crossing the 4. So that will give you a bundle of 5. All right, so the tally column there is just to make a note of each of the data, how many times they are occurring. And then now the frequency column now, what it does, it adds up all the tally that we would have got. And then now we tell the actual amount. So the frequency is the actual amount when we actually finish the tally and add up everything. That's when we get the frequency. Now, so tallying is important because it's a way of, recording the data, keeping check of the data to see how much of that data occurred. As you really want to see or to understand what is happening with this data. You want to get some information from the data. Now, there's in Jamaica, you know that back in the days, banana was very popular, and we have especially in the northeastern parishes, we usually have a lot of banana producing in St. Mary, Portland, and going up to St. Thomas side. Now they usually export banana in large quantities, in shipload. So in those days, when you go to the banana plants, then you will have boxes of banana being loaded and so on. Now, sometimes when people are selling the banana, they sell the banana, and sometimes they wait, sometimes they count how many hands the banana have. And so there's this famous song that we would have learned when we were young. The one said, "They, me said they, They are come and they want go home. Come, Mr. Tallyman, tally me banana. So what it was saying is that on an active plantation, there were workers there tallying the banana, and they say 6 and 7 and 8 and bunch, something like so. So it is actually tallying how many hands on in terms of a bunch of banana. So they would make strokes and put down the frequency of these bunches of banana. And that is a way of helping them to analyze the quality of banana being produced, right? You may have a lot of bananas where you have a lot of hands. Some bananas may have a small number of hands. So that would be information for the producers of the banana and also for the exporters, because they are sending away banana. They want to see that they are sending away quality bananas and so on. All right, so everybody understand the table in terms of the data and the tally column and the frequency column. Now, oftentimes when we're looking at frequency distribution, we would have deleted the tally column because the tally column is actually saying exactly the same thing as what the frequency column is saying. Because when you add up all that you have in the tally column, they amount to the frequency. All right, so oftentimes you get a table, you may not see any tally column in it, right? But at least if they ask you, you would have known what a tally column is like. All right, so we talk about frequency distribution, and we are now going to also talk about group distribution. Now, just to make a note of what the frequency distribution is. So the frequency distribution is when you have a set of data ranging from a certain amount to a certain amount. In this case, the data range from 1 to 8. And then we have the frequency column that tells you how many these what you call it, data occurring. Now, it is all well and good if we are dealing with a range of numbers from 1 to 8. So that's a small range when we are dealing with data. But some data, the range of the data might spread out way further than just from 1 to 8. You may have data with ranges going from 1 to probably 1,000. Now, thinking about you having that range of data to put it on an ordinary frequency distribution like table like this, your data column, you would have to label it from 1 to 1,000. I mean, it's not very practical to do that on a paper, right? So in order to accommodate those large range of data, we now talk about group distribution. Now, what group distribution does, it allows you now to put that range of data. So if you have a data in this case from 1 to 100, you don't want to list all the data from 1 to 100, but you can put them in groups. So you can classify a group starting at 1 and at 10, then the next group starts at 11 and at 20 and so on. By doing that, you will realize that you would have far fewer groups than to write down all of the data from 1 to 100. Because here we have how many groups we would have made from the range. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could easily just condense the data into group so that it makes it easier for our table and makes it easier in terms of representation. So when dealing with a large amount of data, it is useful to group them in classes. The advantage is it presents the distribution clearly and concisely. So you can imagine if you were to list all of the data from 1 to 100, how how it would probably look a little bit challenging to follow. So it wouldn't probably be so clear to work with. Now, it also make the data concise. So it give a concise picture, meaning it shortens the way it would have looked if you didn't have the group. All right, so with that said, we are going to be working with group distribution, our group distribution, as well as we're going to work with frequency distribution. All right, moving along. Now for our distribution, our frequency distribution, if we are looking at group distribution, there are some things or some terms that we need to learn when it comes on to a group distribution. Now, first thing we talk about class, sometimes referred to as class intervals. Now, if you talk about the interval, the class interval here, the first class or the first class interval would have started in 150 and it ends at 154. So that's a class interval. Now, you could look at each class and say that each class has an upper limit and a lower limit. So for each class, the lower number of the class, so the first class you have 150 and 154. The lower number here is 150. So the lower number is the lower limit of the class, and the upper number is the upper limit of that class, right? Now, so we have class limits, and then now we also have what we refer to as class boundaries. Now, there is a distinction between limit and boundary. We don't treat them in the same way. Your boundary is a little bit more exact in terms of how you separate the class or the classes, but the limit itself kind of limit you to a certain range, but it doesn't give you the exact separation between two classes, right? And so the best way to think of limit and boundaries, if you think of it in terms of you having a perimeter fence, most of us, when we have enough money to afford it, we will put up a wall, right? Now, when we use a wall to make our fencing against our neighbors, now the wall by itself does not give you the boundary of where your line is. And why do you think this is so? Ms. Waysam, why do you think a wall would not give you the boundary? Ms. Waysam, I was asking you, I was saying to you that we are trying to get the idea of limit and boundary. And I said the best way we can think of it is think of when we have a fencing that separates our property from our neighbor's property. Now we may put up a wall to separate ourselves from the neighbor. So now what I'm asking you now, I'm saying to you that the wall would not give a very detailed, it wouldn't tell exactly where your boundary is, would it?
Not really, sir.
And why would that be so? Why wouldn't it be able to tell your boundary?
Sir, I'm just looking at basically the size of the block itself and how you would set it down, so it would be either over the boundary or
Right, because you know the block is wide, so your boundary is basically a line.
Mm-hmm.
But when you use the block does not give it the exact line. Some of it will be either on your side and the rest will be on your neighbor's side, depending on how you decide to lay the block.
Yes, sir.
Lay so that the line falls in the middle of the block. Then what we can say, one side of the wall that on your side is a little bit away from the boundary. The boundary would be right in the middle of the block. On the other side of the neighbor, the boundary, that side of the wall would be a little bit over the boundary on their side. So the wall would somewhat split in the middle between the neighbors. So when you think about it then, if this is our wall and the boundary is in the middle, then by using the block, we are limited by the wall when we are going towards the boundary. Because if we are moving towards and we want to go to the boundary, we can only stop where the wall is, right? Because the boundary is in the middle of the wall. So the wall here limits you. So this would be in like the limits, but in the middle of the wall would be your boundary. So when we're talking about classes in terms of frequencies, our group distribution, it is the same principle that we are using. We are saying that your boundary would be falling somewhere in the middle of your class. You follow what I'm saying? Guys?
Yes, sir.
Right. Now, so if you think about these now, think about the numbers now in terms of the class. So let's say that the 150 here is what? The limit. And let's say that this to the left is one class. So let's say that this is the first class. And to the right you have the second class. Then between the first class and the second class, now to the left here, you have another wall. To the right here, you would have another wall. So all of this is your class. And this class starts from what? 150? And it ends at what? It ends at 154. But remember now, these are what? The limits. So the limit would fall where? Right, which part? The wall, where you meet the wall. Now the next class, which would be...
That should be 150 again, or you should have 154.
154 is supposed to be there. I don't know why I put 150, but maybe because I'm a little bit exhausted. All right, so it's 154. Now for the next class, which is the second class, their lower limit going to be what? 155, which is going to start here. And that is the lower limit of that class, but the upper limit of that class is going to be what? 159, right? Now remember that the boundary is in the middle of the wall, because the boundary is a line. Now, so suppose we know then that this limit is 154 and this, so the limit of the lower class here, the upper limit of the lower class is 154. The lower limit of the next class is 155. How can we use these two numbers to determine the middle here? How would you find the middle between these two numbers? What would be the the midway between 154 and 155.
So we're going to take away the 154 from the 155.
Now, but if you take away 154 from 155, would that give you?
Oh,
Would that give
so
you?
repeat the question you asked earlier.
I want to find out what is the number midway between 154 and 155.
0.5, sir. Half.
It can be 0.5.
154.5, sir.
154.5, correct. How do you get that number?
Sorry, because if we have the class limit, which is 154, and the mid boundary, which is halfway, sir.
Yeah.
The halfway would be 0.5, so it would be 154.5, and then the reach over is 155, sir. So you know,
So if you were to use a calculation method to calculate that, what would you do? What you would have to do is to add the two limits and then divide it by 2. So if you add 154 plus 155 and divide it by 2, you will get 154.5.
okay, sir.
Everybody see that? So now the mid value here is what we have. This would be what? 154.
0.5.
4.5. What does this value represent? This value represents what?
Boundary, sir?
The boundary.
mid-
That's the boundary value. You get the idea? So the boundary is different from the limits. The boundary value is the exact line midway between the two classes, or between the two limits. You follow what I'm saying? Is that clear, guys? So let us define these things in a more formal way. But this idea should give you should help you to understand the idea of boundary, the concept of boundary. So here now, we talk about the class interval. So we say that 150 to 154 is called the first class interval. 155 to 159 would be we call that the second class interval. So we can sometimes just call it the class. So you call this the first class. So 150 to 154 can be called the first class. The other one, 155 to 159, can also be called the second class, and so on. All right. Now, so we know the classes, and we know that the classes have limits, and we know that midway between limits of one class and the next class, we're going to have the boundaries. Any question, guys? Do you all following so far? All right, so now we talk about the class limits. And we say that 150 and 154 are called the class limits. And these would be what? Upper and lower limits in terms of the first class. So the 150, which is the lower number, is the lower limits of the first class. And 154 is the upper limit of the first class. Now, next we talk about boundaries. And let us look at how we find boundaries now. Now, in order to find the boundaries, we now have to find the limit of one class, the upper limit of one class plus the lower limit of the next class, we add them and we divide them by 2. So in other words, for the first class, this first class, it has an upper limit of what? 154. The second class has a lower limit of 155. So these two classes are next to each other in terms of the fencing or the border. So how do we find the boundary? We add these two numbers and we divide them by 2. Now, we have what we call the class midpoint. So the class midpoint is in the middle of the class. Now, if we want to find the class midpoint, so this is a class, and we want to find the middle of the class, how would we do that?
Sir, add both class and then divide it by 2.
You add both limits of the class and then divide it by 2. All right, so we add the lower limit and the upper limit of the class and then divide it by 2. So in other words, we're just finding the midway, which is really what we refer to as the average 2. All right, so we would have seen how to find class midpoint. We just add the 2 limits of the class and divide by 2. Now we talk about the boundaries. We would have to now add 1 limit, the upper limit of one class with the lower limit of the next class. Now, if you notice though, if we are to find the first class boundary, the first class boundary would occur at the lower limit of the first class. Do you agree? Because remember, this is a limit. That means there is a wall right here. So the lower boundary of the first class would have been found close to the lower limit of the first class. Is that clear, guys? Now, how would we do that? Now, we would have to imagine that there was a class before the first class. And if there was a class before the first class, then we would also have to imagine what the upper limit of that class would be. So we can just look at the trend or the pattern of the number. So we notice that we have 154 to 155. So which number would come before 150? So clearly we would have to have what? 149, then 150. So we can assume that if there was a class before that first class, the upper limit of that class would be 149. And so to find the boundary then, we would use that 149. So we assume that class limit was already there, which in general, you don't generally have that limit. You will have to just make that assumption by imagining that there is a class before that first class, and then you think of what the upper limit of that class should be. So in this case, we notice that that should be 149.